Okay, so hi, good afternoon. I'm going to be presenting for the Biomaterials Laboratory. So this is a shared space between Fotios Andropoulos and myself. And we had to give it a title, so we decided to call it Biomaterial Development for Vascular Tissue Engineering because we do focus on pro-angiogenic therapies. So basically a bird's eye view of what we do. We first start with a biomaterial selection. So we select a proper biomaterial and then we modify it to render it more adequate characteristics for the intended purpose. Here's an example of a polyethylene glycol based polymer that was modified with nitrosinamide chloride in order to render it gelation capabilities under exposure of a certain wavelength, and it could revert back to its aqueous state when it's exposed to a different wavelength as well. We then combine this, once we're happy with what we got, we combine this with drug delivery capabilities. So we introduce bioactive molecules in order to enhance its effect on the target tissue. And finally, what we do is we utilize different scaffold fabrication techniques to introduce architectural cues, which will further enhance tissue regeneration for the target areas. So here's an example of a freeze-drying scaffold fabrication technique, but we focus mainly on nanofibers-based scaffolds, in particular those that are produced via the electrospinning process. And the reasons is we've been doing this for about 10 years, so a whole decade with electrospinning, and it's very attractive for two main reasons. First, it has unprecedented surface area to volume ratios, and it can introduce both nano as well as micro architectural cues, which has been shown to enhance the reaction of the tissue, right? So again, we saw a good success with the hydrogels that we chose, the biomaterials that we chose as drug delivery vehicles, and we further enhanced that by introducing architectural cues with the specific fabrication technique of electrospinning. Thank you.